Hi, everybody. Welcome to the next part of our lecture for Chapter 8. So, this is Chapter 8, 8.3, Section 8.3, and this is all about Jupiter. So, this week we'll be covering up through Jupiter, and next week we'll continue on with more of the Jovian planets in detail. So, Jupiter is my 100% favorite planet, and it's for several reasons, and not only because it's the largest planet in the solar system. It is an amazing planet and so beautiful. All the different colored bands and the crazy storms that it has, and including things like this giant red spot. And you can see here over time how that red spot here, which is a big storm, like a hurricane. So imagine a hurricane on Earth, just much faster in winds and much larger. It is at times has been as big as the diameter of the Earth, or more than that. So if you look here at the different what's happening over time, you can see that it's actually getting a little smaller as time goes on. So it is changing, but it was first noticed about 300 years ago. So it's been going on for a very long time, this big hurricane-like storm called the red spot. So Jupiter is just an amazing planet. And I want to start with just some images from our Juno spacecraft, which has been out at Jupiter giving back these great color photos of Jupiter. So let's see here, I think we want to just go scroll down. So, all right, so you can see this is one of the photos, these sort of big close-up photos of Jupiter. So a really amazing photo from Juno. So let's show you some of these really gorgeous pictures of the atmosphere. So here you can see these just little cyclone-like storms and all kinds of little cyclones and just this beautiful color. Now this isn't exactly a picture, it's a picture that's been enhanced a little bit with some of the color mapping. So it is very beautiful, and which is why science meets art here is very important. And you can look here. This is the South Pole, and I think this is really amazing. All these little cyclones and little teeny things. This is more like that first image we saw, but this is looking up at Jupiter from the South Pole. Really beautiful, and looking at that red spot, you can see all this detail in the red spot that you really couldn't see from a farther away picture. It's really amazing. All kinds of swirling gases. I mean, it's a beautiful planet. It's, I think, honestly, the most beautiful planet in the solar system besides Earth. Of course, I do love Earth. So really quite amazing. This is a look in the infrared, so I'm not going to show that, but you can see this is actually an artist. This is not a picture, but it is an artist rendition of what lightning on Jupiter might look like, because we do think that there is lightning that happens on Jupiter, in Jupiter's atmosphere, and there's lots of interesting dynamics going on in the atmosphere and around Jupiter. So let's go back to our slideshow. Okay. Whoops, that's not what I wanted to do. There we go. Okay, so it's an amazing place. And we're going to learn a bunch about it and about its moons. Okay. All right, so the interior of Jupiter. So what exactly is it? Well, it's called a gas giant, like you saw in the beginning of this section of the beginning of Chapter 8. Because its composition is very much similar to that of the Sun's, and a lot of its contents are in gaseous form. So Jupiter contains about 75% hydrogen, 25% helium. It's a whole lot. That's very similar to what the Sun's composition is. And there's some traces of heavier elements. Now, at some point, as you sort of go down in Jupiter's atmosphere, it's going to turn into a liquid because of the high pressures from all the weight of the gas above it. And so if you go down to where it starts liquid, then there's molecular hydrogen. That means that every molecule is an H2 molecule. So it's molecular hydrogen, that's what it means. So there's a little bunch of H2s in liquid form down about 1,600 kilometers down. Now, below that, the pressure is so high that these hydrogen atoms get squeezed together so hard that the electrons kind of come off the hydrogen. There's only one electron for every hydrogen. So if you squeeze them together, two hydrogen atoms together, you're going to get two electrons that can sort of move around now because they're sort of liberated from the hydrogen from this high pressure. Now, whenever you have something where electrons can move around freely, you have something that can conduct electricity. This is very important because that electricity, that electrically conducting material, this metallic hydrogen, it's called metallic because it can conduct electricity, is circulating around the planet, really is the reason that it has this very high magnetic field that it has. Right? So we saw before that to get a magnetic field, you need some kind of conducting thing like iron or any other metal. In this case, is metallic hydrogen moving around inside the planet to sort of spin up a dynamo and give you a big electric field. So it's actually metallic hydrogen that's doing that for Jupiter, which is really quite amazing. Now, people think that Jupiter has a rocky core, but it's most likely kind of kind of almost a liquid, right? So it's not quite like a solid rocky core that people don't quite think that's what it's like. And at the temperature at that center is very, very high because of how everything is squozen down at that point. Okay. Now, what about the atmosphere? So we're looking now up at the atmosphere where there's gas, pure hydrogen, but there are clouds of ammonia. So imagine you'd have like an ammonia rain, right? So on Jupiter, well, in Jupiter. And the middle layer of clouds is composed of this sort of ammonia sulfide here. And then there are some water clouds, which is what we have on Earth, right? Our clouds are actually water vapor. And then you have these sort of complex compounds that pollute the clouds and give them their color. So that's why they're such amazing, beautiful colors in Jupiter's atmosphere. Now, you notice when you see pictures of Jupiter that these are sort of dark bands and light bands. So these have particular names. The darker, they're called belts and zones, and the belts are the darker material, and the lighter zones are the belts. Sorry, I mean zones. Sorry, belts are darker, zones are the lighter ones. And the darker belts are high pressure material that's arisen from the deeper regions, right? So you have this really high pressure stuff. It's coming up to the surface in these bands, in these dark belts. And then the lighter zones, those light areas that you see here, right? These zones of the light areas are actually are regions of stuff dropping down. So lower pressure material dropping down into the lower regions. And this is all being driven by heat, convection, like a boiling. So it's almost like Jupiter is boiling, right? Which is what convection is. It's a very interesting, and a lot of the energy of that heat coming in from convection is driving the movements of the gases in the belts. All right. Again, Jupiter has a really strong magnetic field because of that metallic hydrogen. Large magnetosphere, that's that region around Jupiter that has high magnetic fields that are trapping charged particles. And that gives for, these beautiful auroras like we have on Earth. And you can see here right at the poles, we actually have pictures of these auroras happening on Jupiter. So quite amazing. Okay, time for a question. Pause your video.